Hello guys, this is our Wednesday video, our third video, and we're going to start our geometry booklet in this. And a lot of this you have done in school, so I am going to go at some speed. And I know I do speak fast. Anyway, so pause as you need to, though I want to get stuff done, okay? So in all these, ladies and gents, they are straight lines. So if it says y, if a question says why is this 88 or whatever it is? Yeah, I believe it is 88. Then the reason is angles on a straight line add up to 180. Anytime we see this symbol, we need to write 90 by it. Okay, that'll happen quite a lot there as well. Okay, so straight lines are 180. Okay, full turns, angles in a full turn, in a full circle, if you want to call it that, add up to 360. The rule here, if you had to ever describe why it is that opposite angles are equal. So that is opposite there, so that's 20, and that is opposite there, so that's 160. And again, same there, opposite angles. Here we're using that angles in a triangle, the interior angles of a triangle. The interior angles of a triangle add up to 180. Same for the next three. However, we're looking at a special type of triangle, isosceles triangle. And what we're using with the isosceles triangle is that there are two equal angles, okay? Namely the bottom two, the two at the bottom of these, okay? So if the top one there is 30, take that away from 180 and you get 150. And then half that, meaning that this is 75 and this is 75. The final rule on this page is that angles in a four-sided shape, or we call it a quadrilateral, add up to 360. Pen's not the best. Okay, so add up what you know, and take them away from 360 to get the missing one. Again, anything that's got that symbol, just write 90 by it. That's a 90-degree angle. So the application, that one's easy enough. Right angle triangle adding up to 180. This one, be careful of the kind of not wording as such, but how we talk about angles. So find the size of ACD. It doesn't even say angle ACD. Three letters like that, ACD, particularly with a little roof on the C. Okay, start at the first letter, go to the next letter, C, and then over to the D, and you can see you make an angle with those there, and you make that angle there. That is the one they're looking for here. This is called ACD. And importantly, the little roof on the middle one tells us where exactly the angle is. It's at C, but it's coming from A and going to D. Now, to get that one, we can't start. That is an exterior angle, and we'll talk a little bit more about exteriors in a minute. Right, but in order to get the exterior, you're going to need to first know the interior one. So you're going to need to use the rules of triangles adding up to 180, and the fact that these two are equal. I think they come to be, what is it? 180 take away 34 is 146. Half 146 means these are 73 each. And then the exterior and this interior of 70 add up to 180. So I can take those 73 away from 180. Often you'll have to borrow from the middle number because you're taking away from 180 or 360. It's 7, 1, so 107 for the exterior there. Same with this one. They're looking for an exterior angle, but we would start by working out the interior. We get this one first and then take this one away from 180. And to get the interior, this time it's a four-sided shape, so we've got to make sure that they add up to 360. Okay. One angle in a right angle, that's naughty, isn't it? In a right angle triangle, well, if it's a right angle triangle, one of the angles is 90, right? Then it says one of the others must be 60, and your job is to find the third angle there. Well, they've got to add up to 180, so the third angle must be 30. And three of the angles in a four-sided shape add up to 250. So to make them add up to 360, the other must be 110. Next topic. Now, I'm not going to say much about here. Here, right? Here, you're given the exterior, so you can work out the interior by taking that away from 180. And once you've got two of the interiors, then we're going to use the fact the angles inside a triangle add up to 180 to get that one. You do that. Miss out that one for a sec. Miss out that one for a sec. And I'm going to focus in on this one, right, just to show you. Okay, you've got your parallel lines are going up here. So this is angles in parallel lines, okay? If that's 74, that's 74. We could also then take the 74 away from 180 to get these to a 106. And then up here, we got a 1, 2, 3. So fill in everything around here. So these would be 57 each. And then basically, guys, you're trying to work out like the ones that they want. So let's start with A. A is in that position, which is the same as that position up there. So A is also a 1, 2, 3, whereas B is in the same position as this 57 here, so it's a 57. So that's using that group there is the same as that group there. Then we've got a different line coming at a different angle through the parallel lines. So you got your 74, 74, 106, and the C is quite clearly in the 74 position. It's in the same position as that one there. Okay? Right. I'm not too bothered about interior angles, so I'm going to steer wide of these ones. The only one I'm kind of interested in here is the first one because it's a four-sided shape. And we know four-sided shapes are 360, so we can work out the missing one. However, I need to have a look at some of these. Earlier on, I talked about exterior and interior angles. Interior, exterior, okay? Add up to 180. Interior, exterior, add up to 180. Now, there's another rule that we could add to our angle rules, and that is that exterior angles, no matter what the shape, if it's a triangle 3 sides, a 4-sided shape, a 5-sided shape, a 6-sided shape, it doesn't matter. Exterior angles will always add up to 360 degrees. So if I say, what is, and I'm going to write an extra question here, what is the exterior angle? What is the exterior angle here of a shape that has 6? No, let's go for 3 sides. Okay, then I would need to do 360 divided by 3, which is 120. Therefore, the exterior angle is 120. And once we know the exterior, we can get the interior, again, by taking that away from 180. So the exterior is 120, the interior is 60. So the alternative of that is, instead of them telling us the sides, what if they say, okay, a regular polygon has exterior angles of 45? Well, we need to remember exterior angles add up to 360. So if each one of them is 45, if I know how many 45s will make 360, that'll tell me how many sides this shape has got. And the answer here would be 8. Now, problem with the next one, it talks about interior angles of 135. No good to me. It's not interiors that I'm interested in. It's exterior, so I'd need to take that away from 180 because these are the ones that I know add up to 360. So again, look, it's actually the same shape as the one above. It's an 8-sided shape, but I've needed to work out the exterior. So here, exterior is 36. How many of those go to 360? Whereas here, interior was 135. Well, that's stupid because we've already done 135. So let's muck about with that and go for the interior is, what am I going to say? Oh, look, 120, say. Right, the interior is 120. How many sides does the polygon have? Well, take that away from 180 first of all to work out what the exterior angle is, and then try and see how many of those go into 360 to see how many sides it's got. Circle theorems. I'll do this now, even though I'm going to do tomorrow. Okay, four of them to learn. Number 1. If we have a line across the center that makes a semicircle, so I'm going to write what the rule is here. The angle in a semicircle is 90 degrees. What I mean by that is this. If you draw a line straight across, like this one here, or this one here, or even if it's in a funny angle, it's still going straight across and through the middle, right? creating us two semicircles, and you just draw two lines from the side. The angle that is made on the edge is 90 degrees. Now that you know that that's 90, you can work out the missing angle here by going, well, 90 add 65, 155, take that away from 180, and you get that that's 25. So there's your first circle theorem. Angle in a semicircle is 90 degrees. This one, you're looking for this specific shape. You're looking for this. Now, the rule is this. The angle here, which is at the center of the circle, so O in these cases, is double the angle here. So for example, here, if that top one is 51, that one is going to be double that and will be 102. Or vice versa, if the middle one is 122, the top one is going to be half of that. Now, in words, something like angle at center is double angle. Now let's keep it simple. I could say angle on the circumference or something like that, but I would just call it the top, right? They're not that bothered on the word, and as long as you kind of give, and that's only if they ask for like explanations as to why. But generally, that's it, right? The next one is one I call the bow tie, and I'm looking for this kind of setup. And if I get this kind of setup, the top angles are the same, and the bottom angles are the same. So here, if that one's 50, that one is also 50. If this one down here is 30, this one down here would also be 30. And the rule will be angles at the top are equal. So whereas the angle at the center is double, but think of it as you're looking for a bow tie. Here you're looking for what I call an arrowhead. Here you're looking for a semicircle. And the final one. We just said that four-sided shapes, the angles inside a four-sided shape add up to 360, but there's a little bit more. If that shape is inside a circle, so for example, 1, 2, 3, four-sided shape inside a circle, they still add up to 360, but there's an extra rule. The two opposite each other here will add up to 180, and the two opposite each other here will also add up to 180. So if we look at this one here, we've got a four-sided shape here. Y would be 140, making those two add to 180, and X would be 109, making those two add to 180. Here, they need to add up to 180, and so do they. Then that makes 360. So that only happens when the four-sided shape is inside a circle. So if we were going through this, here's what I'd be looking to do. Right. I'd be looking to find, I'm just going to check how long is left on my video, about 3 minutes. We can get this in hopefully. Right. So here, I'm not going to give you the answers here. I want you to look at these. Here's the deal. There is no semicircle. That line is not going through the center. There is no arrowhead. There is no bow tie. So the only one I'm left with is there a four-sided shape in here? And there is. One from A to D, D to C, down to B, and back up to A. We've got like a four-sided shape. So what we know about that is that the two angles opposite each other will add up to 180, so you can work that one out. Then, nothing to do with circle theorems, you've got a little triangle up here, and so if you know this one, and you know this one, then you should be able to work this one out, because they should add up to 180. In the next one, let's see if we can spot any of these now, right? Semicircles, arrowheads, bow ties, four-sided shapes, okay? Now, I can kind of see an arrowhead here. Can't see a bow tie or a, I can see an arrowhead. The arrowhead one is this, that the angle at the center there is double that one. It's double. That was our rule for that one, okay? Also then, that's not actually, we need to put that one in there, but that's not actually the one we want. The one we want is down here. But what you've got down here, sneakily stuck in, is a little triangle, and actually it's a special type of triangle. Even though they're not marked, it would be isosceles, because both O to A and O to B will be the same length. So actually, if you know that, and you know you've got an isosceles triangle, you should be able to take that away, this angle here in the middle and take it away from 180 and half it to get those. And finally, oof, there's lots going on. Lots going on. I can see the little arrowhead. I can see that one. So that one is double that one. But I don't know either of them. But I've also spotted that there's a four-sided shape here. Look, A, B, C, D. So I know that these two, which are opposite each other in the four-sided shape, will add up to 180. That allows me, I guess, to work that one out by taking 126 away from 180 to get that one, and then doubling that one to get the one in the middle. That's circle theorems. That is it. Okay? Right. I'm going to leave this right there. Lovely people. And then I'm going to come back with our Thursday video, which hopefully will cover most of the rest of this booklet, if not all of it.